Here is our final project for the big data class. We're focusing on the stock trend prediction by using historical stock data. We have two team members in our team. I am Yucan Liu.
And I am Yuxin Liu.
Our team name is Byron. First of all, according to the rule of the stock market, there is an invisible hand behind the market, which means the stock market should not be predictable, but we think the stock market has some invisible inertia relationship between the stocks. For the data part, we using a Python script to gather all the daily data from the stock market about all stocks. The whole size is about 1.26 gigabyte. It's including date, open, close, high, low, and all those features. For this project, we specifically use data of date, open, and close. The data manipulations are done by using Python PySpark. The techniques we use in this project includes time series in R, clustering, and regression. The software we use includes RStudio, Python, and PySpark. First of all, we imported our data into R. Here are two examples about two stocks. This is a stock about Jingdong, which is a Chinese company. And here is another stock. Finally, we imported a stock called Alibaba, which is a Chinese Amazon, into the RStudio, and we got this seasonal decomposition function. You can see the first line is data, second is a seasonal, the third is a trend, and the fourth is a remainder. Then we also applied hot winter forecast on the Alibaba's data. We actually got 3 days output, which is 175, 176, and 178. Actually, we did pretty good prediction because the real market is 174 and 175, which is really close to our prediction. However, if we use a single stock's historical data to predict the stock itself, we find the error might be giant in the long run, so we decided to go to the second part of our project.
Yeah, so we can find that if we just use the single stock's historical data, we will have very large error in predicting long time stock. And then we have this big idea that we can find some correlations between stock data with our target data, but they actually have a d-time delay, so we can actually use strongly correlated stock data to predict our target data. And first of all, we started off exploring with some basic machine learning regression techniques. We explored ridge, lasso, random forest, and boosting regressions. And then we added kernel k-means to the regressions to find the strongly correlated data with our target data, and the results are shown on the right-hand chart. The green shaded parts are actually when adding the kernel k-means increase the prediction accuracy, and the red shaded parts are where adding it actually decreased the prediction accuracy. The maximum difference increasement we got was 3.79%, and the maximum accuracy we got was 54.0%. And we then tried using co-integration, which is also a way of finding correlations between stock data, to find the correlations. So we can see on the right-hand chart that the majority is still shaded green, which means that adding co-integration to the regressions actually increased our prediction accuracies in general. And the maximum increasement we got was 5.4%, and the maximum accuracy prediction accuracy we can get is 53.4%. So in conclusion, we can see that time series works well on predicting the single stock trend by using its historical data, And from the numerical perspective, the k-means works best with lasso regression, and the co-integration actually works best with random forest regression. And for our time delay technique, when the time delay is actually larger than 100 days, the delay window method actually has a visible improvement. Our project actually has great business values because we analyzed a single stock data to evaluate the stock's future performance by using its historical data. We also use different models and methods to predict stock market in order to gain profit. We try to build relationships between stocks in order to predict changes in related realm and warn in advance. We can move the time window to gain a better performance in the prediction.